Let's start, guys. So yesterday, what we have seen some, yeah. So we have seen some concepts like skewness and curtices, okay, which will help us to understand how much our distribution is differing from a normal distribution, okay, how much it is differing from a normal distribution, okay, and different types of curtices, fine. So any doubts in curtices, guys? Because yesterday you said you need to go through the class. So did anybody gone through the class? Any doubts in this section? Okay, fine. So now today we are going to see new concept called as how to find out if a given distribution is normal or not. Okay. So I think yesterday we have started this concept, right? Did I show you the visual inspection? Did I show you the histograms? Can someone confirm?
From here you need to
Okay.
start.
Fine. So now, how to find out if a given distribution is normal or not? So I think by this time, you might be 100% convinced that we are trying to use normal distribution as much as possible. Okay, the distribution is directly normal distribution. We are lucky. If not, then we will try to convert it into normal distribution. That's a different concept. But before that, first of all, if we are given a distribution, first of all, we should be in a position to understand whether the distribution is normal or not. Okay. So, but you might be thinking, sir, just if we draw, okay, by looking we can understand, right? It's not always okay because we are having small data sets. That's why it might be easy, but you should also have some mathematical or statistical techniques to find out if a distribution is normal or not. Okay, this is we are just checking. So there are three ways by which you can detect or decide if a given distribution is normal or not. Okay, one is visual inspection, one is QQ plot, one is statistical test. Okay, so one is visual inspection. That means just by visualizing the data set, you can have some understanding. Okay, so I think we have already seen this. So yeah, so using KD plots, okay, we have drawn the diagrams, and this looks like almost like a normal distribution, right? So just if you plot a KD plot or histogram plot, or using SNSD bond, if you plot a distribution plot, it will give you both. It will give you the histogram in the background, and also it will draw a distribution graph, PDF graph also. Okay, by this visual inspection, you can understand whether it's a normal distribution or not. Okay, see, this is looking like a near normal. It is not exactly normal, as you can see. This is a near normal. Okay, but how much it is differing from normal distribution, that for that you can again go and use these concepts. Okay, so you can find out the skewness. Okay, yesterday we have seen how to find out the skewness, just data frame dot skew, and you can compare with these values whether it is very much differing, whether it is having more than 0.5 or less than minus 0.5 skewness. Okay, or coming to curtices, over here the excess curtices is how much. Okay, whether it is near to zero or it is very much in negative or very much in positive. Okay, you can find out skewness and curtices. Okay, and decide whether you can consider or assume that as a normal distribution or not. Okay, that is one concept. That is just a visual concept. But one statistical method, one famous method which we have is called as QQ plot, guys. QQ plot. Okay, so we are going to see this. Okay, coming to statistical tests, there are few tests like Shapiro-Walke. There are different tests. Okay, so we'll be discussing once we touch those concepts. Okay, but today we'll be focusing on the QQ plot. Fine. So now let's try to understand QQ plot. Fine. See, first of all, in statistics, a QQ plot, quantile plot. Okay, what does QQ plot mean? Quantile plot is a probability plot. Okay, a graphical method for comparing two probability distributions by plotting their quantiles against each other. Okay, so a point on the plot represents of one quantile, second distribution plotted against the same quantile. Okay, this defines again. Okay, the basic point is this. This is a plot. Okay, what is saying? This is a plot It is called QQ. That means quantile quantile. The why it is called quantile quantile, because this graph is made up from the quantiles against each other. Okay, you'll have two graphs. Okay, so you'll have two, if you need to take two distributions. Okay, two distributions, and you need to find out quantiles of q1, let's say quantiles of first distribution and quantiles of other distribution. Okay, then you need to draw this graph. Okay, again, that means what you are plotting the quantiles against each other. Okay, all quantiles of this graph, all quantiles of this graph. Okay, and based upon this quantiles, if you draw a graph, and if at all it is, let's say if at all it is falling on the straight line, fine, then we can do some assumptions. Okay, that is a basic idea. That means plotting the quantiles against each other is QQ plot, guys. Okay, the basic definition is just plotting the quantiles of two graphs against each other is a quantile plot. Okay, but how you can use this to find out the normality is interesting. So when I said you can just plot two graphs, fine. So here what we will do is, here we will take one q1, let's say q1 as a normal distribution. Okay, we will take a normal distribution, and q2 as a test distribution. We will take this as a test distribution. Okay, now we already know that the q1 is a normal distribution. Okay, we intentionally took it as a one normal distribution, but q2, okay, but q2 is some test distribution. Okay, and now if both of these, okay, if both of these quantiles are plotted, and if they're following a straight line, okay, that means this test distribution is a normal distribution. Okay, that's the idea. Okay, because when you're plotting quantiles of two distributions, and if they are following a straight line, which means that both are similar distributions. Okay, both are similar distributions. Okay, so that's why to find out normality, we will take one distribution as normal and other distribution as our test distribution. We'll draw the quantiles. Okay, so that's the basic idea. We'll understand using a example. Okay, so that it will be clear for you. So let me go. Oh, this notebook's right. Okay, sorry, I forgot. Today I will try to share. Yeah. Or also, can someone remind me in the group right after sometime in the afternoon? Okay. If I don't share it soon, so can someone just put a message to share the notebooks? Okay, I'll just arrange this and share you. Okay. So now coming to normal distribution QQ plot. So here we are checking if a distribution is normal or not using QQ plot. Okay. So what I said, you need to have two distributions. Okay, X and Y. Fine. So now we are using the sepal length example. Okay, sepal length example. Now sepal length is from where? Iris data set. Okay, iris data set. I'm converting it into a list. Okay, and I'm sorting it. Why? If you remember, if you want to find out quantiles, okay, if you want to find out the quantiles, the data should be in the sorted order. You remember that? Quantiles. Okay, here if you see, this is the data, and this is in the sorted order. Okay, it should be the sorted order. So only then we can proceed for the quantiles. Similarly, here also, the idea is to find out the quantiles of two distributions. Okay, one is normal distribution. Let's say one is normal distribution. Okay, this will assume, but this is our test distribution. So we are testing whether this X is a normal distribution or not. Okay, we don't know. Now let's say if X is our not, okay, here I have to Y, right? So I also take Y. So now let's say Y is our test distribution and X is a normal distribution. Okay, so I don't know whether Y, which is my sepal length, is a normal distribution or not. Okay, I want to test it. So what I'm doing, so I need to find out quantiles. Okay, quantiles of Y. Okay, and also quantiles of X. Okay, so how to find out quantile? Just take the data set. I'm converting into a list. Okay, I got the sepal length and find out the mean. Fine. So now how will get the quantiles, guys? So just np dot percentile. Okay, so I'm creating a list called y quantiles, y quants from I in range of 1 to 101. Okay, that means 1 to 100 it will take. Okay, that means what? 100 percentiles I'm taking. Okay, see here, np dot percentile. Okay, and inside that sepal test. Okay, that means my data set sepal test comma I means what? For initially it will take 1. So that means I'm considering np dot percentile sepal length of 1. That means 1 percentile of sepal test. What is a 1 percentile of sepal test? That means my sepal length. It will calculate and it is appending to y counts. Okay, it's appending to y counts like that. 2, 3, 4, 5, like that. 100 percentile values it is considering and it is appending to my y counts. Clear? See. Okay, so once I do this, let me show you y counts. Okay, see, this is the first quantile. I mean, first percentile, not quantile, first percentile, second percentile, third percentile. Okay, like that. Okay, fine. So, and this is a 50th percentile. Okay, 5.8. Okay, 5.8 is the 50th percentile. That means what? It is a median. Agree? Do you remember those concepts? Median. Okay.
Yes,
Uh,
Santosh.
in the sense, what did we take? Sepal length, right? Sepal length. Okay. In this data set. Okay. Okay. This sepal length median will be 5.8. Okay. And these are all the quantiles. Okay. Every quantile. And obviously the last one will be the maximum value 100 percentile. Okay. And this is a minimum value. Okay. Fine. So now this we already know. But the point what we don't know is whether this sepal length distribution is a normal distribution or not. We don't know. Okay, fine. Now, see, you can think that, sir, we can just plot it, right? Yeah, we can plot it, but I'm just showing an example statistically because if it is small data sets, you can plot, but if it is a complex data set, it will be difficult. Okay, because let me first of all just plot it and see how does my sepal length look like. Okay. Yeah, so this is my sepal length, right? Yeah, see, it's a quantile. What is this? This is a KD plot. This is looking like normal. Okay, this is looking like normal, but just small deviations. Okay, just small deviations. Okay, almost it is near normal. Okay, fine. So now coming to KD. Okay, so just give me a second. There is some. Okay, fine. So now coming back. Where are we? Yeah. So now this is what did we do? We have calculated the quantiles of our sepal length. Okay. Next, what I said, one is our, see, yeah, one is our like what is our y? Y is our like test data set. Okay, and other thing is a x data set. Okay, this is x. This is normal distribution. We'll take it as normal distribution. Okay, so how you can take? We are creating np dot random dot normal. Okay, from there you're taking the mean, standard deviation, and then size. Okay, using this we are creating a normal distribution samples. Okay, and this is samples dot mean. Okay, agree, samples dot mean. Fine. And this is definitely a normal distribution because we are intentionally creating np dot random distribution and dot normal. Okay, normal distribution. And for this also we need to create the quantiles, sorry, percentiles. Same thing. So you are creating np dot percentile samples. Okay, you are taking 1 to 101. Okay, so it will also create 100 percentiles. Okay, and if I show you, see, these are the 100 percentiles. Okay. So by looking at this, can you just guess what type of normal distribution is this?
Uh, it is greater than -1. It is not in
No,
between.
I'm asking by looking at this graph, okay, or by looking at these values, can you guess what type of normal distribution is this?
Standard normal.
It's skew now.
Right. It's a standard normal distribution. Okay. There will not be any skewed normal. Karthik, it will be either normal or it will be skewed.
Yeah.
Okay. But this is clearly, see guys, it is clearly, what is this mean, right? I told you log LOC is mean, and this is what standard deviation. So mean
Yes.
equal to
Yes.
0, standard deviation equal to 1 is a standard normal distribution. I think
Yes.
I have mentioned this at least 200 times in the last 2 classes. Okay. Mean equal to 0, standard deviation equal to 1 is a standard normal distribution. Okay. Fine. So now using that, but that is also a normal distribution. So we are taking the quantiles of that. Okay. And these are the different 100 quantiles of it. Okay. And now, okay. So this is a quantile median value. Okay. That's fine. Now the point here is, as I said, so what is saying simple. So he's saying a graphical method, okay, where comparing two probability distributions by plotting their quantiles against each other. Okay, you need to plot their quantiles against each other. That's it. So, and here one plot corresponds to quantiles of the second distribution plotted against the same quantiles of the first distribution. Okay, so for second quantile you are plotting against the first quantile. Okay, just take the quantiles, plot them. That's it. So we have took the quantiles of this data set. Okay, y cons and normal distribution we have created, and x cons is a quantiles of the what is this normal distribution. Okay, you can call it as percentiles also, quantiles, percentiles. Okay, fine. So now if you just plot them against each other, okay, SNS or seaborn dot scatter plot. Okay, dot scatter plot is just it's like a it will not create any continuous graph. It is a dotted graph. Okay, it will just plot the points. Okay, scatter plot x and y. X is x cons, y is y cons. Okay, once you draw this, okay, see, can you see? It is almost like a almost following a straight line. Agree? Only there is some deviation over here. Okay, a small deviation. Okay, almost here clear. Okay, so same thing. So here also when we see here, it is almost looking like a normal distribution. Agree? So that's why the graph will be in the straight line. So what it is doing, it is comparing. So on the x-axis, okay, on the x-axis we are taking a normal distribution. Okay, on the y-axis we are taking a test distribution. Okay, can you see the graphs? This -2 to 0, 1, 2, 3. Okay, what are these measurements? What are these values? These are from the x cons. Agree guys? If you see the x cons, these are in the -2, -1. Okay, something like that. Fine. And if you see the y cons is having the value of -4. Okay, some integer values. Agree? So that's why you can see y cons is plotted over here and x cons is plotted over here. Okay, and when we are plotting each quantile, that means what it is doing, first percentile of, okay, first percentile of this x samples. Okay, let me call it a sample, first percentile of sample data set, which is normal data set. Okay, I will call it as normal so that you'll understand it is normal. Okay, first percentile of normal, comma, then it is doing what, first percentile of test. Okay, you'll have one data set. Agree? You'll have one data set. Okay, let me write it here. Okay, what it is doing, to taking normal distributions first percentile, okay, comma, sepal length. Okay, sepal length first percentile. Okay, to plot scatter plot will do nothing guys. Okay, in the xi space, it will just plot a point. That's it. Okay, like that every point will be scattered. Okay, that is scatter plot. To point any, sorry, to point any plot any point in the space, right? You need to have two coordinates, x and y. Agree? Any point we have two coordinates, x and y. So here one is x-axis is a normal distribution of first percentile, and y-axis is a sepal length first percentile. Okay, like that normal 2p, 2p, like that, 100p, 100p. Okay, so we have 100 points, it will plot all the 100 points. Agree? So once you do that, so the graph, it looks like almost a normal distribution. Okay, so this is how you can statistically prove that given distribution is almost a normal distribution. Okay, is this clear, guys? Let me know. Any doubts you ask me? Theoretical, practical, anywhere? Or is this clear to everyone?
Clear, Santosh.
Clear, sir.
Okay, so now you'll be able to use this and find out if I given a distribution, you can easily find out if it's a normal distribution or not, right? And instead of doing all these things what we have done, so there is this have shown you the in bits and pieces according to the definition how you need to do, calculate the quantiles, etc. But directly you have using the stats model, okay, using the stats model.api as SM. Okay, so what you can do in this SM, there is something called as QQ plot. Okay, just import the stats model.api as SM, take this SM, inside that you have QQ plot. Okay, and just give whatever you want to do. Okay, so here you need to just pass your data frame or data set column, which, okay, test distribution, and you just need to give line is equal to 45. That means this is a 45 degrees line, right? So you're checking over there. Okay, and here you don't need to give any corresponding normal distribution. Okay, because by default it will take normal distribution, because if I show you SM QQ plot, yeah, so this is SM QQ plot. So how did I get this? So the sm.qq plot. So if you say, so always go through the official blogs or official websites, guys. Okay, so for every module you are using, right? So it will have a official website. Okay, always follow only that. For matplotlib, pandas, numpy, I will show when we come across that. But stats model. So this is the official model. So the official website. So here, if you see in the QQ plot, so this is the actual graph. Okay, actual library. So inside this, you need to give data, distributions. Okay, all these are default parameters. Okay, but here mainly what we are giving. So we are using what we are using. We are using data, and then we give only line. Okay, but according to QQ plot, what is the actual concept? You need to give two distributions. One is our test data set. One is another normal distribution to compare these two. Agree? But why we are not giving any normal? Because if you see over here, data is data which we have given. Okay, but comparing distribution is a distribution. Dist, we have a parameter called as dist. Okay, here you need to give the comparing distribution. But the thing is, the default is scipy.stats.distributions.normal. Okay, this means it is a normal distribution, a standard normal. Okay, a standard normal distribution. Okay, so by default it will compare with a standard normal distribution. Okay, by default it will compare with the standard normal distribution. So that's why you don't need to give specifically as a normal distribution. Okay, by default it will compare with normal distribution. So that's why we can just give df equal to sepal length and just remove it. So by default it will take dist equal to, if you don't give anything, don't think it is not considering, it will take the default parameters. Okay, so we'll see this hyperparameter in detail, but since we came across, so see guys, when we are plotting a QQ plot, fine, so it will consider all these parameters whether you give or not. Okay, if you give any specific value, it will consider that. If you don't give, it will take the default value. Okay, see, I not take I not give any LOC over here. Can you see any LOC? No, it has considered the default value. Okay, similarly for distribution also, I not give any value, it will take the normal distribution. Okay, by default. Agree? So sepal length. Okay, and after that, see line. What is line? Line is options for the reference to which the data is compared. Okay, 45 degrees degree line, A is standardized line, A is regression line, A is all different lines. Okay, we'll take for the 45-degree line. Okay, so to find out this line, red color line. Okay, once I plot this, okay, once I plot this, so I'll show you. See, using this also, it is almost, see, this part is perfectly normal. Okay, here is slight deviation, here also slight deviation, here is bit deviation. Okay, and in the edges, and also here slightly it is deviating, but more or less it is looking like a normal. For practical purposes, you can consider it as a normal distribution. Okay, so using SM stats model, you can directly do it. Okay, you don't need to do this always. Okay, this is for your understanding. So, but given any distribution, just use a QQ plot, put it in, give a data set, just line 45, just say fit equal to true. You can see the distribution. Okay, so but QQ plot is very important, guys. Okay, Curtis is that's a different concept. You may not use that much. Okay, but QQ plot is very important. Okay, because what happens is when you are actually working, right? So when you're actually working, so in a project, so you will be given a data set. Okay, fine. You'll have the rough raw data. Fine. Then you will start, for example, on any bike project you're working. Okay, to predict the bike sales, etc. Okay, so you'll have column 1, column 2, like the different columns. So fundamentally, if you want to start using, okay, all the related uh, concepts of the normal distribution, like if you want to find out the PDFs or CDFs and say empirical formula, okay, and a lot more which we are going to see in future. So first of all, you should be sure whether this is a normal distribution or not. Okay, otherwise you cannot do that. Okay, so that's why most of the time first check is to find out whether a given distribution is normal or not. So that's why, let's say you will take C1 and then you will plot a QQ plot. Fine, you will find out the skewness, you will find the curtices, and also you will find out you will plot a QQ plot. Okay, based upon that, all things you will do, you'll do visual inspection, you will just plot a KD plot. Fine, by that, by looking, you will get some idea. Then you will find out the QQ plot. Okay, and if it is like this, it's perfectly normal. Okay, but if it's slight deviations, then to understand how much is a deviation, so you can find out the curtices and skewness. Okay, from there you will get slight idea. Okay, skewness is slight, skewness, curtices is a little positive, a little negative. Okay, from there you can you can understand with how much confidence you can assume that as a QQ plot. Sorry, you can assume that as a normal distribution. Okay, so once you are convinced that this can be considered as a normal distribution, then your life will be easy. Okay, then all this comes into picture. Okay, you can say this, that, everything. Mainly outlier detection. Fine. In the case of outlier detection, we have seen, right, any graph, okay, any value which is like greater than 3 normal distributions or less than minus 3 standard deviation. Okay, greater than 3 standard deviation, less than minus 3 deviation. Okay, this graph, you remember this? Okay, here this will be mu. Okay, 3 row minus 3 row. Fine. So first thing is, most of the data set what you get, right, they will have outliers. Okay, because that is raw data. Nobody will fine tune and nobody will do processing. Nobody will do some what is it, filtering and give you. Okay, they'll just give you the raw data from directly from the consumers or from the some websites, or okay, mostly it will be the raw data, unclean data. Okay, then it is bound to have some outliers. Okay, you can expect definitely they will have some outliers. So the easiest method is to use the standard normal distribution concept, where anything greater than 3 row or minus 3 row, okay, will be an outlier. Okay, to use this concept, you cannot use it for any distribution. You cannot, let's say, use this for some exponential distribution or some binomial distribution, for example. Okay, so to use this, first of all, you should be confident that your distribution is a normal distribution. Okay, so that's why these things are important. So first of all, you need to check. So using this QQ plot, you can check and you can conclude, okay, because of QQ plot, this distribution, okay, because of this visualization, okay, and because of this amount of skewness, this amount of curtices, I am concluding. Okay, in your Jupyter notebook, you need to write when you are working on a project, you need to explain everything. You should write, okay, based upon these assumptions, I am considering this, my distribution is a normal distribution, and hence then you will go and assume what all you can do. You can just remove the outliers using this. Okay, and then you can calculate quantiles, percentiles, empiricals, everything. Okay, so that's how you can do the QQ plot. Okay, theoretical. And this is how different types of QQ plot look like. Okay, see here, if it's a normal, perfectly normal distribution, okay, the QQ plot looks like this. Okay, and if it is a data is little bit peaked, okay, you see the background this bars, okay, little peaked. Okay, so in that case, the QQ plot will be a bit tilted. Okay, you will miss the graph. And if it is skew data set, okay, this is right skew data set, okay, and then also the QQ plot will be slightly deviating from the normal distribution, okay, because this line is a normal distribution, okay, this line is a normal distribution, okay, and this plottings is for your data graph distribution, okay. How much it is deviating from that, you will be understanding, okay. So it is normal this way, okay. So that is a point, but there is one more important point actually, which is a general misconception, that most people will think QQ plot will work only for normal distribution, which is not true. Actually, QQ plot doesn't only work for normal distribution, but any distribution, okay. QQ plot will work for any distribution, okay. So nowhere in this actual definition, okay, this is a Wikipedia definition, you cannot see any mentioning of the word normal. He's just saying it will just compare two probability distributions. That two could be anything, okay. Just plot their quantiles against each other, and it will say whether those two distributions are alike or not, okay. Using that, you are taking an advantage of this concept and applying it for normality test, okay. And this is the most famous application of QQ plot, okay. Mostly we will use it for this, but generally speaking and strictly speaking, it is not confined to only normal distribution. No, you can test it for any sorts of distributions, okay. So we are going to see that, okay. For example, if you come over here, see QQ plot for a uniform distribution, okay. So instead of normal, so if I consider a uniform distribution, it works. So here what I'm going to do, so np.random, okay, uniform distribution, I'm just trying to create some random data of uniform distribution, okay. And if I plot, okay, this is looking like a uniform distribution, okay. So after that, in stats.uniform.fit x, okay. So here I'm fitting, okay, from the stats module. So I'm considering the uniform.fit x, the above x, I'm fitting to a uniform distribution, and stats.uniform, okay, I'm creating a distribution stats.uniform, okay, parameters, okay. From here I'm taking 0 and 1, okay. You're creating a, here you are actually creating the, when you're doing fitting, right? So uniform.fit, okay, what's happening over here is, in simple words, this is actually creating a uniform distribution, okay. Here we are randomly taking some values and generate some uniform distribution, but to see how much this is uniform distribution or not, we will see, okay. But here when you're fitting, this is from the stats module, you are taking the uniform distribution, which will be a perfect uniform distribution, okay. So now you have two distributions, just come over here and just plot. Yeah, see here what I'm doing here, this is my x, okay, which is randomly created, and I want to see whether this is a uniform distribution or not. So using the sm.qq plot, okay, I'm giving x, and here dist equal to distribution I'm giving, okay. In earlier case, here you don't need to give anything, just you give the data, sepal length, and just you say line 45, and that's it. So by default it will consider what? Dist equal to, by default it will consider normal distribution, standard normal distribution, okay. But if you don't want to take the default value, here you want to specifically test for the uniform distribution. So that's why in case of other distribution, you need to pass some parameter to this dist, okay. Here I am passing dist is my uniform distribution, okay, which you have fitted, okay. This is actual uniform distribution, and x is your randomly generated uniform distribution, okay, above, and you want to compare these two, okay. So now you are comparing this actual statistical uniform distribution with your randomly generated uniform distribution, okay. And the line is 45, okay. So now if you plot this, okay, see, these are the theoretical quantiles, sample quantiles, and when you plot, so this is almost similar as expected, right? So this is from the statistical distribution, so which will uniform. Here you have okay, randomly generated a uniform distribution, which will be almost like a uniform distribution, okay. You will have, so now it should be clear in your mind that QQ plot, basically it will just try to compare two distributions and tell you whether they are same or not. That's it. That's the only job, okay. Don't confine or don't fix QQ plot for normal distribution, no, okay. General usage of is any two. I have shown you normal and uniform, you can take any distributions, okay. So you can take skew distribution, both skew. See, you take one is skew distribution, second thing also skew distribution, doesn't matter for QQ plot, it will just tell you whether both are same or not, okay. Same thing, uniform, anything you take, okay, it will just tell you, it will plot the quantiles and it will tell you how much both are same or not, okay. But usually we don't want to compare skewness or uniform distributions. Okay, the famous application of QQ is for the normal distributions. Okay, since you can take any distribution, so mostly we will take one out of this Q, one we will fix it for normal distribution, and then another Q you will take test some test sample and we'll check how much it is different from normal, or test 2 test like that. Okay, which is a famous application is a normality check. Okay, normality check is a famous application of the QQ plot. Okay, but generally speaking, you can use for any graph. Okay, so that's how you can use a QQ plot. Okay, for almost any distributions. Okay, so that's about the QQ plot, guys. Let me know if it's clear. Will you be will you find it easy to apply it to any new data set? Let me know.
Yeah, Santosh, I have small doubt.
Mhm.
So for QQ plot, definitely we need two quantiles, right? One is for a random, one is for
Some distribution, yes.
by using only two, like for one is for x-axis and one is for y-axis.
Right.
So can you please? I mean, I did not understand. Like, can you please show me the QQ plot by using statistics
Oh,
thing?
okay. See,
Where
using
I can see
statistical,
only I can see only one data.
that's what I'm saying. Here in the sm.qq plot, you are passing only test data set.
Yes, correct.
Okay. But with what it is comparing, that is your doubt.
Yes.
See, that's what I said. Here, what is the actual library definition of QQ plot? So so in QQ plot, okay, so you will have so many parameters. See, Karthik. So if I
So
go here,
you said like by default it will take, right?
right,
There is the yeah, okay.
right. That means you don't need to give dist parameter. Okay, so see, simple. While checking for the normal distribution for sepal length, I did not give any dist parameter. Can you say any dist parameter? No.
No.
Even if you don't give, don't think that it did not use dist parameter. Definitely, as per the library, see, this is a definition. Okay, this is a syntax of this QQ plot. Okay, whether you give or not, 100% it will consider all of these parameters. From where it will consider, so there is for every parameter there will be a default parameter. Okay, for example, see a equal to 0. Okay, a equal to 0. That means what? If you give some value to a, okay, it will consider that value. If you don't give value to a, it will consider 0 value.
Okay. Yeah,
Okay,
those
similarly
things I
for the
have
distribution
understood.
also.
Yeah, I thought I mean only remaining one it will take default. Definitely for data set and we need to okay.
Yeah,
Got it.
correct. Only for data set you need to give. Here I don't need to give any default. I mean, here I don't want, I don't need to give any default. But I think if you want to give default distribution, so we have created a normal distribution here, right? So what is normal
Yes,
distribution? This is
yes.
our samples, right? So I think if you want to give, you can give dist equal to no samples. What is saying? As no attribute dot fit. D of samples, okay, X and Y and line, okay, X and line. Attribute name. Okay, let me create samples. Okay, this is we are randomly generating, right? Okay. Yeah, I think we need to create a normal distribution. Okay, we need to create a like this one stats.normal distribution. We need to create stats.normal. I'm just checking whether we can create by this. In stats it's not normal. Okay, I can show you, but I'll show you later. Okay, but here it's not needed. What I'm trying to do here is just to create a normal distribution and use it fit. Okay, but using QQ plot by default it will be normal only, right, Karthik? So you don't need to worry about the distribution. Okay, you can
Sure.
directly by default it will take the normal distribution. Okay, but for other distributions, let's say for uniform, okay, for uniform, okay, you need to specify the distribution because see, I will show you. Because if I don't give distribution over here, okay, what it will do, guys, by default with what it will compare?
By default, it will take normal.
Normal. Okay, so now if you see, okay, so this is my normal. Okay, this red axis is my normal distribution, because by default normal. And see, this is like a uniform distribution. Okay, this is like a uniform distribution. So obviously there is so much change. Agree? So you are comparing uniform with normal, so obviously both will be very much different from each other. Getting, guys? But here, if I specify distribution equal dist, which is our uniform distribution, then it will compare uniform with uniform. Agree? Fine. So is QQ plot clear, guys? Everyone, before I move to next distribution.
Yes, sir.
Okay, fine. So after that, we are going to see, okay, a distribution. So now see, normal distribution is done. Okay, we have seen a one famous distribution. Okay, then we have also saw how to check some normal distribution. So from this point of time, so we'll be seeing few other distributions. Like we'll see many distributions. Okay, all of these distributions, I'm saying important to learn, but I cannot guarantee you are going to use all of them practically or not. Okay, but somewhere or the other, directly or indirectly, you will have a use of it. Okay, so you will see normal distribution, you will see Pareto distribution, you will see Bernoulli binomial. Okay, you will see Poisson distribution. Okay, four-way distribution, Feynman distributions you will see. Okay, fine. So first, let's try to understand log normal distribution. Okay, see, log normal distribution is, in probability theory, a log normal distribution is a continuous probability distribution of a random variable whose logarithm is normal distribution. Okay, thus, if a random variable x is log normal distributed, okay, then y equal to L of x as a normal distribution. Simple, don't get confused. Here it is saying log normal. See, normal distribution is what we have seen till now. Okay, there is some other distribution called as log normal distribution. Okay, which is also a PDF, continuous probability distribution. Okay, whose logarithm is normally distributed. Okay, by default, graph is not normally distributed. Try to understand. By default, graph is not normally distributed. Okay, but that means whatever the x you are having, let's say the data set is x. Okay, this x is not normally distributed. Okay, but logarithm is normally distributed. That means log of x. Okay, log of x. Okay, when you do log of x, okay, this is normally distributed. Getting? Okay, so you are having a data set. Okay, if you just plot it, okay, if you just plot it and see, that may not be a normal distribution. Okay, but when you draw, when you take a log, okay, you know how to apply log, right? So just log of some value and apply to every point in the data set, and if you plot this log of x, that will be a normal distribution. Okay, so we will see. And but in simple words, log normal distribution is a kind of right skewed distribution, guys. Okay, trying to understand. It will be like a right skewed. Okay, because if you see, this is normal distribution, this is normal distribution, and this orange color, this is log normal distribution. Okay, but forget about normal or log normal. How does this distribution look like, guys? It's look like a skewed distribution. Okay, and it is a right skewed distribution. Agree? It's a right skewed. This right side is skewed distribution. Agree? So usually log normal distribution is a right skewed distribution. Okay, it will be right skewed distribution. Fine. And but there is an important point. All right skewed distributions are not log normal. Only whose log is normal, only those are log normal. Getting? No, confused. See, simple. I'm saying you have normal distribution, that's fine. Okay, but log normal distribution is a distribution where it will right skewed. Okay, it will be skewed. right skewed. But all, okay, all right skewed, okay, right skewed are not log normal, or not log normal, because you can have lots of log right skewed, right? You can have lots of, okay, even this could be not right skewed, okay, or this could be right skewed, any right skewed you can have, okay. All these are not log normal, okay, okay, but every log normal distribution is a right skewed, okay. The reverse is not true, but log normal distribution means it is right skewed, but all right skewed are not log normal, okay. But only those right skewed distributions, only those right skewed distributions whose log, okay, whose log values, okay, log of x are normally distributed, okay, only this type of distributions are called log normal distributions, okay. Because you can have some other log, some other right skew distribution, okay, you can have, this is some other right skew distribution, okay, but if you take log of this, okay, if you take this log of, let me call this as some z distribution, okay, if you take this is a right skew distribution, okay, this is a right skew distribution, okay, but if you take log of this z, okay, this might not be a normal distribution, okay. So then even though this is a right skewed, this is not a log normal, this is not a log normal distribution, because the log of this distribution is not a normal distribution, okay. But if at all a distribution whose logarithm, okay, whose log values are following a normal distribution, that is considered as a log normal distribution, okay. Is the definition clear? Any confusion, tell me, I'll explain again, but tell me, is the definition clear?
Yeah, clear, Santosh.
Okay, fine, simple. Whose log value will be normal distributed, okay. Directly it will not be normal distribution, okay. And this is actually, you know, this is actually can be practically seen also, because I'll tell you, see, simple, most of the values, okay, that means what, guys, see, practically we'll understand when I'm saying right skewed, okay, that means what, right side it is having more values, okay, right side it is having more values, that means in any distribution it will start with the low value, it will have a peak value, that means majority of the values are falling here, and some extreme values are having with low frequency, okay. See, what does this right skew distribution mean, guys? We'll see. It has started, what is this value on the y-axis, sorry, on the x-axis, what is this? X-axis is values, x-axis actual values, and y-axis is what? Frequency, okay. I hope you remember that y-axis is a frequency. That means in the right skew distribution, what happens, it is slowly the frequencies, that means when the value is increasing, okay, when the values of the x-axis are increasing, okay, x values are increasing, slowly the frequency of this is increasing, okay, the frequency is increasing, okay, but and again it is decreasing, okay, like normal distribution only. Normal distribution also slowly it will increase, it will reach a peak value and it will decrease, right? Here also it is happening, but here the speciality is, okay, there are some extreme values, some extreme, as you can see this graph, okay, it is going over here like this, that means on x-axis it is taking some extreme values, agree, on x-axis it is taking some extreme values, okay. See, this graph is going like this, okay, that means it is taking some extreme values on x-axis, but with what frequency? Very little frequency. The y-axis is very small, okay, this y part is very small, but on the x-axis, see, from 0 it has went through almost here, okay, that means it is taking some extreme values, let's say 10, okay, but with very small frequency. Agree, guys? Are you understanding the graph? Because this graph understanding is very important. If you understand this, you will understand the examples, okay. Normal distribution is simply it will increase and it will decrease, but log normal, okay, or right skew distribution, or specifically log normal distribution, it will follow a normal distribution till certain value, but after that in the right side, that means in the higher values of x-axis, okay, as x value is increasing, there will be some values whose x-axis will be very extreme, but only some values, the distribution is very small, frequency is small, because this height is frequency, right? On the y-axis it is frequency, okay. You'll find extreme values of y-axis with small frequency. Is the graph clear, everyone?
Yes, Santosh.
Okay, fine. So now we will see the examples. This is practically possible, okay. So one famous example is the yearly income, Okay, yearly income is actually a log normal distribution. Okay, see, usual our salary is like 10k, 30k. Okay, mostly see 50k average salary. Okay, it has started. Okay, the distribution is what? 5 million people. Okay, 10 million people. Okay, what is this graph actually? Forget about the log normal everything. What is this? This is saying 10,000 people earning people are how many? Okay, this is how much? Some 7 million. Okay, like that. 30,000 earning are some 11 million. Okay, 50,000 earning are 15 million in India. Okay, so like that. Again, when you are increasing the salary, the graph is decreasing as expected. Okay, high, few people will have less salary. Okay, as expected, it is having. Okay, when you are increasing, it is expected. But if you see this is right skewed because if you elongate this, there will be extremely, when see 1 million, 1 billion. Okay, people who are earning 1 billion, that means extreme values on x-axis will be very very low. What is the distribution? Okay, here the distribution is very very high. Okay, this y-axis, and decreasing, and by the moment you reach here, very very low, a couple of people, just not less than like 100 people. Okay, like Ambani, Musk, Bezos. Okay, few people will have extremely high values. These people are responsible for this skewness. Agree? These people are responsible for skewness. Okay, that's why in a log normal distribution, very extreme, okay, very few people, okay, very few people will have extremely high amount of values. Okay, so the frequency and which will result in this skewness. Okay, see, usually to stop here, but because of the very, okay, some set of people, okay, the extreme values can be found with small frequency. Okay, with small frequency, you cannot remove this guys, but actually that's the reason. So even though they are occupying a small frequency, but these guys are the important. Fine, these guys are important in GDP or in the wealth creation or everything. Okay, most of the people, most of people, regular people will fall over here. Fine, 9 to 5 jobs, normal small jobs. Okay, but if you see, the people who run the world are actually these people. Agree? Who will be found at the end of this skewness. Fine, whose wealth will be very very high but with very less frequency. Okay, so these type of graphs, okay, these type of graphs, right skewed. Okay, this is right skewed. Okay, this is a example of a log normal distribution. Is the example clear, guys?
Yes, Santosh. Okay.
Okay, so we'll see an example, practical example, how you can do the log normal. Okay, so I'm taking the income. Okay, see, I'm taking the income data set. So where I'm having just income and the count. Okay, so now if you see, okay, I'm just importing the data set. Okay, income and count. So when you plot the distribution, okay, this is just regular SNS plotting parameters. The main thing here is SNS dot bar plot. Okay, so this is just, first line is just a figure size. Okay, how much this figure size should be. Main thing is a SNS cbond dot bar plot. Okay, these are all bar plots. Agree? X is income, Y is count, and data frame is a DF. Okay, and next thing is these are the tick label. That means these values. Okay, this 500,000, 10,000, whatever you're having, right? So those are the values. Okay, and the rotation. Okay, these are all just parameters, guys. Don't worry about this. You can go through the official website. Okay, these are simple. But main thing is how we are plotting this. Okay, so when you plot this, as you can see, this is clearly a log normal distribution. Do you agree with me? It's a log normal distribution, clearly. Okay, why? So as you can see, it is right skewed. Agree? Log normal distribution. Fine. So now when we apply, okay, when we apply, so what did we discuss? The actual distribution will not be normal distribution. Okay, the x will not be, x is not normal distribution. But what will be normal distribution? Log of x. Logarithm of x will follow a normal distribution. Okay, those type of distributions are called log normal distributions. Agree? So here same thing we are taking. Okay, but in the place of x, okay, now we are considering the log scale, not the normal scale but the log scale. Fine. So when you take the log scale, okay, when you take the log scale, so here if you see, this scale, okay, on the x-axis, the scale is normal scale. But here we are considering the log of values. That means we are changing the scale. So if you see the scale is like 10 to the power 0, 10 to the power 1. Okay. Here you can, even though it's not completely normal, okay, it is near normal. Okay. You can at least see some normal distribution sort of thing. Okay. This is not a perfectly normal. So okay, I'm just showing you example. Okay. It is at least resembling a normal distribution. Okay. Still there is some skewness, but still it will try to convert it into a normal distribution. But here you can clearly see it is a clearly right skewed, completely right skewed. Okay, completely right skewed. Okay, but here once you take the log of this, it will try to convert it into a near normal distribution. Okay, near normal distribution. Okay, so that is how you can calculate the log normality. Okay, but the fundamental point is, the only point you need to remember about the log normal distribution is the distribution by itself will not be a normal distribution, but logarithm of the values will create a normal distribution. That's why it's called log normal distribution. Okay, is it clear, guys? Let me know, is log normal clear? Everyone? Okay, fine. So the last distribution which we are going to see, a small distribution, but very interesting distribution. Okay, very much helpful in our practical purposes, is called as Pareto distribution, guys. Okay, so yeah, Pareto distribution. Fine. So now see.
Tomorrow, sir.
Tomorrow. It will just
Yes,
take 5 minutes, Siri. Do you have 5 minutes?
Okay, sir.
No. See, only if you have, you tell me, because understanding the concept is important. Okay. If you really have 5 minutes of time, tell me. Or no, you can tell me.
Tomorrow we continue.
Okay, fine. Same with you, Meghana, right?
Yes, sir.
Okay,
Gates
fine.
are closing at 9 o'clock only, sir, so we need to go fast.
Sorry, what is closing?
College gates are closing at 9 o'clock only, sir.
Acha. Okay. Fine. Understood. Okay. So fine, guys. Go through the concepts. Okay. And only one thing I would say is practice some QQ plots. That is important. Log normal, you will not find it that often, but QQ plots are very important. Okay. Practice the QQ plots and yeah, try some examples. Okay. Fine. Tomorrow we'll start with the Pareto and we'll see some important concept. That is the transformations. Okay. Fine, guys. I hope the class is clear. Okay. Let's meet tomorrow.